Alright, today we're going to be solving int32 to IPv4 on Codewars. It's one of the easier problems. It's 5 KYU. And so here we go. Take the following IPv4 address: 128.32.10.1. This address has 4 octets, where each octet is a single byte, or 8 bits, of course. First octet, 128, has the binary representation, and that's got to be 128 in binary. The same for 32 in the second octet. The third octet, 10, has the binary representation of that. And the fourth octet, 1, has the binary representation of just all zeros and then a 1. So this IP address, 128.32.10.1, if you put it all together like this, the binary representation of 128 dot binary representation of 32 dot binary representation of 10, and the fourth octet 1 is just 1. But you could put all of these together and turn them into one integer, into one number, and of course that's a 32-bit integer. Because the above IP address has 32 bits, we can represent it as the unsigned 32-bit number, and that number is shown here. Complete the function that takes an unsigned 32-bit number and returns a string representation of its IPv4 address. And here's some examples. So of course, this long one here goes to the IP they've given us at the beginning. 32, of course, is just 0.0.0.32. And 0 is, of course, just 0.0.0.0. So we can see that we have a function in Swift called IPv4 of i32 u int unsigned integer 32-bit, and we're going to return a string given that unsigned integer. Okay, so it seems like we're probably going to need some bitwise operations, or somehow break this down into the 4 different parts. Get all the bits out of these 32 bits and break them up. Turn them back into a string. So let's see what we can do with this. Okay, let's take a look on Google, and maybe there'll be something. Oh, all right. Looks like there's an extension where you can actually change the behavior of uint32 and add this functionality to return the string, which would be pretty useful. And sure enough, they're just getting the self of the actual integer, making this local variable or local constant right here. Let IP is equal to self. Then they're going through and they're using the bitwise operators. Which I'm sure we could look through the documentation and find out more about how to do those. Unfortunately, it looks like we're going to have to actually reverse the order, because someone says that this solution isn't quite correct, but we can still go ahead and copy and paste this into our solution right here. Okay, and I'm going to go ahead and fix that bug. There we go. And now all that's left to do is return i32 dot IPv4 string. All right, let's give that a test. Oh, I forgot to include the extension part. Okay. Give that a test now. And I passed all the tests. So let's go ahead and submit that. And right after we submit this, we can see what other kinds of solutions they have for us in Codewars. Excellent. You may take your time to refactor or comment your solution and submit when ready. Well, I think I'm ready. The test passed. And I'm ready. And we can see that the most popular solution was actually just leaving that extension part out. But the code itself looks like it was exactly that. And then here's some other solutions. Just putting that same code into the return statement inline. Or doing something here with unsafe bytes and all this other stuff. But it looks like Google was good to us, and our solution seems to be pretty good. So that's it. Hopefully we'll solve some more problems later.